Welcome to the deep dive. Today we're tackling Docker Compose. It's one of those tools that really promises to untangle some developer headaches. Our mission here is pretty straightforward. Unpack how it simplifies those complex multi-part applications. We've looked at technical guides, even a beginner's blog, aiming to give you a quick way to grasp this pretty powerful concept.
That's exactly right. Docker itself, amazing for single applications. But when you start adding parts, like a web service, maybe a cache, a database, all needing to talk, trying to manage that with separate Docker run commands, it gets messy fast. A real tangled mess sometimes.
Oh, wait.
So this deep dive will show how Compose is like a project manager for your containers. You define everything once, run it with one command, simple.
And the payoff for you listening in is pretty big, we think. Maybe you're prepping for a meeting or just trying to get up to speed on new tech, or you're just curious. This should give you the core ideas, that practical understanding, without drowning you in details. Let's get into it.
Okay, let's unpack this then. We know Docker's good for single containers, but what is Docker Compose exactly? And I mean, why does it make life so much easier, especially when apps get bigger?
Yeah, so Docker Compose is specifically built for defining and running multi-container Docker apps. That's its job. It's real power. It uses a single configuration file, usually called docker-compose.yml. It's a YAML file. And in that file, you configure all your different services, your containers. It just makes starting, stopping, even scaling the whole application stack way, way simpler.
Okay, I've definitely been there chaining Docker run commands together. Feels clever for a minute, but then why is Compose fundamentally better than, say, a really smart shell script? Especially as things get complicated. That's a great point.
Yeah.
It really gets to the why. See, Compose lets you treat multiple containers, not as separate little boxes, but as one cohesive application. Everything needed, the web server, the database, the cache, it's all described together in that single YAML file. That makes it super easy to read, to share with teammates, to version control it with Git.
Consistency?
Exactly. And it's not just convenient. It means you can set up different configurations for, say, development versus production easily. Imagine telling your CI/CD pipeline, just run Docker Compose up, and knowing it's the exact same environment as on your machine, that wipes out so many works on my machine problems. Huge win. Plus, and this is big, it handles the networking between the containers automatically. They can find each other, talk to each other, without you setting up complex Docker networks manually. I remember burning hours on that before Compose, trying to get containers to see each other. This tool really does save a lot of that kind of pain. And when we talk about the core concepts, the pieces you work with in Compose, there are really three main things. First, services. Simple enough. These are just the containers you want to run, your web app, your database, your cache, whatever.
Okay.
Second, networks. These define how those services, those containers, connect and communicate. Compose sets up a default network, usually. And third, super important, volumes. These are for persistent storage. You need your database to keep its data even if the container stops and restarts. Right? That's what volumes are for.
Okay, services, networks, volumes. I think I follow. Can you maybe give a quick analogy? How do those three kind of fit together?
Yeah, sure. Think of it like building a small town for your application. Each service is of building the house is your web app, the bank is your database, maybe the coffee shop your cache.
Right.
The networks are the roads connecting all those buildings. Let traffic, data flow between them. And volumes. Those are like secure storage vaults or warehouses in the town. They hold the important stuff, the data, safely, even if a building gets, say, torn down and rebuilt. The data persists.
That makes sense. So that brings us right to the blueprint, the docker-compose.yml file.
Yeah.
What exactly are we defining in there? What goes into this file that builds our application town?
Right. This YAML file, it's the declaration for your whole multi-container setup. You specify which services, which containers to run based on images or Docker files. You dictate how they connect using those networks. You can define custom networks too if needed. You also say which ports on the container should be exposed to your host machine so you can actually access the app. And critically, you configure those shared volumes for persistent storage. So your database data, user uploads, whatever needs to stick around. Once you've written that file, the commands, super simple. Docker Compose up brings everything online, all the services. And Docker Compose down stops them all and cleans up the containers and networks it created. Really neat.
Okay, theory is good, but seeing it makes it click. Let's make it concrete. Can you walk us through a really simple example, like that Flask app with a Redis cache you mentioned?
Absolutely. It's a great, simple way to see it in action. So imagine a basic Flask web app. All it does is count page visits. Super simple. And it uses Redis, just a fast in-memory data store acting as a cache to keep track of that count.
Okay.
The project structure would be pretty standard, maybe a folder called docker-compose demo. Inside, you'd have app.py, that's the Python code for the Flask app. It connects to a host name called cache. That'll be our Redis service, and it just increments a counter there. You'd have a requirements.txt listing Flask and the Redis Python library.
Standard Python stuff.
Yep. Then a Docker file. This tells Docker how to build the image for our Flask app. It might start from a Python image, like python.3.3 copy the requirements, install them to pip, copy the app.py code, and set the command to run the Flask app. But the real key, like we said, is the docker-compose.yml file. It's usually surprisingly short for simple cases. You'd have version 3.9 maybe, just specifying the compose file format version, then a services.section. Under that, you define your services. Let's call them web and cache.
Web for Flask, cache for Redis.
Exactly. For the web service, you might have build.east that tells compose. Build the image using the Docker file in this current directory. Then ports. 5000.5000, that maps port 5000 inside the container to port 5000 on your local machine so you can reach the web app.
And here's an 8 part, depends.cache.
So it waits for Redis.
Precisely. It tells Compose, hey, make sure the cache service is started and ready before you start the web service. Avoids those connection errors when the app starts too fast. It handles the startup order. Then, for the cache service, it could be as simple as image.redis.6. Just tells Compose to pull the official Redis version 6 image from Docker Hub. No custom build needed for that one. And Compose handles setting up the network so web can talk to cache using the name cache. It's pretty slick.
Okay, so you've got an app.py, the Docker file, requirements.txt, and the crucial docker-compose.yml all set up in your project folder. From inside that folder, you just run docker compose up build. The build tells it to build the web image if it needs to. And then you'd see logs from both services, right? Output from Flask starting up, output from Redis. And if all goes well, eventually Flask says something like, running on http.0.0.0.500. It's up. Now, my first instinct after that is always, open localhost 0.5000 in my browser. See the page. But what if you're working on a server? Or maybe you just want a quicker check without opening a browser window. How do you test this multi-container app is actually working, from the command line?
That is such a practical question. And yeah, it's kind of an aha moment when you realize you don't need the browser.
Yeah.
There are actually 3 really good ways to test this kind of setup right from your terminal. Super useful in headless environments like servers or CI/CD pipelines. Option 1, it'll curl. Just run curl http.localhost.5000. Yep. You'll get the raw HTML output directly in your terminal. Like, hello, you have visited this page 1 time. Quick and dirty check. Option 2, a bit nicer maybe, is httpy. If you haven't used it, pip install httpy. Then you run http://localhost.5000. It gives you like pretty printed, colorized output. Shows the HTTP status code, headers, and the body. Really nice for checking APIs.
Okay, I like the sound of that.
And then option 3, this one's really powerful sometimes, test from inside one of the containers. You can run docker compose exec web curl http://localhost.5000. The exec command runs curl inside the running web container. This is super handy if Docker is running in a VM or somewhere remote where localhost on your machine doesn't actually point to the container's port directly. You're testing the connection from within the Docker network itself.
Ah, right, if Docker's inside a VM or something.
Exactly. So these non-browser methods, they work anywhere. You have a terminal. They show you the raw response, the headers, status codes, great for debugging. And frankly, they're often faster than opening browser just to hit refresh, especially when you're iterating quickly on an API. Oh, and one last bit on commands. When you're finished testing or developing for the day, just remember Docker compose down. That stops the web service, stops the cache service, and removes the containers in the network they were using. Keeps things tidy.
Right, cleanup is good. So let's wrap this up. If we boil down this deep dive, the absolute core takeaway seems to be Docker Compose just takes the pain out of managing applications made of multiple services. You get that single command to spin everything up, spin everything down, no more juggling individual containers. It really is a game changer for keeping development consistent and, well, sane.
Exactly. It streamlines the whole process. And by getting comfortable with Compose and maybe these simple testing tricks like using curl or http://, you really gain the ability to develop and test effectively anywhere, including those headless servers where production apps often live. It's a crucial step, I think, towards mastering those more realistic production-grade deployment workflows. It connects your local setup to the real world better.
So here's a final thought for you, our listener, to chew on. What does this mean for your next project? Even if it's small, maybe try adding a second service, like we did here with Redis for a simple cache, or maybe a small database. Use Docker Compose to manage them together, just taking that first step. Getting comfortable with a multi-service setup using Compose, that's a skill that seriously levels up your development game no matter what you're building.